Hi, I'm Adam with FiN Robotics Network, and I'm standing here with 868 TechHOUNDS. The TechHOUNDS was already coming off of a phenomenal season with 2 district event wins and a division finalist at their World Championship division, but now they're coming back with another phenomenal robot. So far, they have made it to be the overall first pick of the event, looking phenomenal all throughout quals and finished ranked 4th. Here they're going to show some of the great decisions they made from their passive funnel into their end effector, all the way into how they, manage their algae and how they managed to avoid many absolute encoders here on Behind the Bumpers. So Sierra, why don't you tell us a little more about how the coral scores and the path it takes to, reach the reef?
Yeah, so coral enters through the passive funnel right here. The funnel centers the coral. It can come in from many different angles, but it works quite consistently. It then goes on to the manipulator. The smaller wheels here in the manipulator are what grab the coral, and then the cone here is what centers it, so it's in the same position every time. This then pivots through the elevator. We also have a figure 8 belt here so that we can avoid gears. It's simple and it hasn't worn down too much. Once through the elevator can go up to any position needed, and it can score on all 4 levels. To handle algae, we have a 4-bar intake right here that can intake algae from the ground. The manipulator then comes out, the elevator would go up a bit, and the large 4-inch squish wheels right here grab the algae. Once we have it, the elevator pulls it up through the 4-bar, and we can score up in the net and in the processor. We can also intake algae with just the manipulator right here, and we can grab it off of the reef.
Thank you. So now going on to Nate, why don't you tell us a little more about that elevator? Now, you guys chose a different approach, going with the continuous elevator. Can you tell us a little more about why you made that decision?
So, of course, one decision behind our continuous elevator is that at any given point, there's less mass moving and it can accelerate faster. That enables us to get that really short cycle time and up-down stow motion that we want. Sarah, can you help me move the elevator up so that we can take a look at the gearbox? Let's see. So the whole pivot and manipulator assembly weighs about 10 pounds. And you can see down here, we have this dual spool contra-rotating gearbox on 2 Krakens. If you want to take a closer look, they're geared together so that if one Kraken fails, it can still move. And it's only a 3-to-1 ratio, which is extremely fast for a continuous elevator. Of course, it also sounds pretty nice if you want to drop it. Go ahead. It sounds
durable
great.
too.
Yes. We went through a lot of testing with this, and ultimately it's taken a lot of design to get the hard stops right, the pulleys right, so that they don't break anymore. Going on to our end game, we have this funnel climber. Through here, the cage will go in through this funnel and latch onto this hook. The pivot will move up here, and the algae intake will go out, of course, to facilitate that. You can see over on the far side of the bot, it's very open there. Unlike a lot of other teams here, which have a kind of pointy climber where you have to align it very precisely, this minimizes that. So we have a sub 8-second climb. Once the cage is in here, we use 2 Kraken X60s with a 9-to-1 reduction to pull this Dyneema string, which winches it down. We have this little ratcheting wrench right here to lock it, and then it can easily be folded down to declimb. You'll notice that a lot of our mechanisms are very front heavy. The elevator, pivot, algae intake. We had to actually balance the climb out with some 8-pound steel in our bumpers so that it lays flat, and you can see that in our matches. On the drivetrain, we use these really custom yellow TPU wheels. Over the summer, we went through about 4 main designs and then countless iterations of this final design to get the most grip on the field.
Nice. Thank you again, Nate. So now we're going to move over to Gavin, so you can tell us a little bit more about some of the software side. Now, some of the key things you pointed out is you have an auto aim, you have some LEDs to kind of signal to your driver, your singular driver at that, how to, what position it's in and different things like that. And you've made an interesting decision to avoid any absolute encoders on this robot.
All right, so I'll start with the vision. So in our front of our bot right here, we have 2 cameras. I decided to put 2 cameras here to get a better view of the tags on the reef, because this is the side of the bot that faces the reef to score. And so we use these cameras to do our auto align, which how we do it is we calculate the pose that our bot needs to be away from the reef in order to score each level. So when our driver is driving, he'll drive to wherever he wants to score. and he'll drive like 90% of the way there, and then he can hit a button, and then the bot will calculate the closest reef branch to the bot currently, and it'll automatically move to that branch and then move to the pose that will score for that branch. And then moving on to our LEDs, let me turn on the bot. And they take a second to turn on, but our LEDs, they give a lot of important information to our driver. And so whenever he's trying to auto align, the LEDs will show him what level coral he's trying to score, for example, and then it'll show that until the bot actually gets to the position where it's good, and when it actually reaches the pose, and then the LEDs will turn green to let him know that he can score because the bot is in the correct position. So you can see here are LEDs. They're not just used for the driver. They can be used whenever we're setting up for a match, because before each match, what we do is we put all the mechanisms of the robot in their correct zeroed position where they should start, as so. And then we decided this year not to use any absolute encoders because absolute encoders have been unreliable for us in the past. And so what we do instead is we have a little button board which is connected to the digital inputs on our Rio. And so what we do is each button corresponds to a subsystem, and then when we press each button, it zeroes a specific subsystem, so we put it in a known position that is repeatable each time we start a match. And then the LEDs, they will change to green, as you saw, once we know that every subsystem has been zeroed and is correct. And so that way we can mimic the effect of having an absolute encoder, which is repeatable positions for mechanisms, without actually having to install absolute encoders and deal with them. And it's not just absolute encoders that we decided to do away with. For our manipulator, we decided not to add any extra sensors like beam brakes, because last year we had reliability issues with them too. Like, they detect a note where there wasn't one, they wouldn't detect a note where there was one. And so what we did this year is we just did current spike detection instead. So whenever the manipulator intakes a game piece, the motor will draw a bigger current, and so we detect those spikes, and then that way we know if the manipulator has a game piece without needing any extra sensors, and it's been working really well for us. And so this year we've decided to just really minimize the amount of sensors that we have to minimize the points of failure that we have.
Thank you all again for showing off your beautiful 2025 season robot Hydra. You will be able to catch TechHOUNDS both at the Washington District event week 5, the state championship week 6, and then quite possibly the world championship in Houston. Thank you all, and have a wonderful rest of your season.